Hey folks, how's it going? This is Mr. Murray coming to you with a video on right triangles and the geometric mean theorems that concern them. Okay, so in this video I'm going to explain to you what are these two theorems, so-called alt-GM or alt-GM and leg-GM, and how do they relate to this triangle that we see here, specifically a right triangle. I'll break it down by showing you why it works with the symmetry, okay, and not with the symmetry, rather with the similarity, okay. I'll talk about some common types of problems that you'll see with these, and this is not meant to be an end-all be-all list of the types of problems, but some kind of common ones that come up, okay, and give you a sense of how the problem solving process works. Then there'll be some that I do or we can do together, and then there'll be some for you to try, okay. So I'm just going to go ahead and jump right in there, and I'm going to start by talking about what are alts or alt-GM and leg-GM. So suppose we have this triangle right here, this right triangle, okay. Now what I'm going to do is I'm going to drop this altitude, okay, and for all intents and purposes, let's assume that this altitude forms a 90-degree angle with the hypotenuse of the triangle, okay. So what I've done here is I've created three similar triangles, okay. I have this triangle right here, okay. This is going to be my, I'll call this maybe my blue triangle. I've got my red triangle, and then if you think about the original triangle I started with, right, I've got the green triangle. Now they're similar because of this idea, right? Now look, they all have a 90-degree angle, right? They're right triangles. Also, if you look at the blue and the green, you'll notice that they share this common angle, and every angle is congruent to itself. So that shows you that the green and the blue have to be congruent by angle. If we look at the red and the green, we can see that they share this angle. So that means they have to be angle congruent because they have this angle in common and it's congruent to itself. They have a right angle as well. So that means that the red and the green are angle similar. So we have the blue and the green angle similar, the red and the green angle similar. But now we also have this. So if you were to measure these angles, I'm looking at now with the red and the blue. Notice that they again do have a pair of, there is a pair of right angles, so that's angle, okay. Now technically they do have this side, but we only have side or side angle side. As it turns out, we were actually able to measure precisely, and we were able to figure out that the angle, this angle here, is actually congruent to this angle here. The other thing we know is this: if the red shape and the blue shape are both similar to the green shape, they also have to be similar to each other. Because think about it, the red shape sides, by virtue of the fact that it's proportional to the green shapes, right? The red shape's sides are proportional to the green shaped sides because they're similar. The blue shaped sides are also proportional to the green shaped sides because they're similar. But that must then mean that the red and the blue are also proportional to each other, because if they're proportional to the same shape, they have to be proportional to each other, okay? So let's look at an example of this. So let's take a look and let's label these. So I've got A, I've got B, and I've got C. That will form our triangle A, B, C. And then the point where the altitude touches the hypotenuse, I'm going to call that D. Some other notation we sometimes use, we can call the two pieces, right? Because B essentially is this line BD, or the segment BD, is essentially splitting the hypotenuse into two pieces, X and Y. We sometimes also call the altitude, this is the altitude, we sometimes call this H for height, And then it's also good to have notation for the sides. And commonly, just like a triangle, right, we know that we have a squared plus b squared equals c squared. Those leg markers are also put in as well. Okay, so I'm going to try to see if we can figure out where are these formulas coming from. Like, how am I going to find a, b, x, y, etc. And in doing so, we'll talk about some of the where these strategies come from. Okay, so to recap, look, I've got, let me just get that out of there. I've got the red shape. Here's the red triangle. Boom, boom, boom. Okay, so I have A up at the tippity top, D down by the right angle, and B off to the side. Now, here's blue. Okay, this one's a little bit easier oriented. I've got H. Let me just quickly label this one. Sorry. I've got A, and I've got X. Okay. Here, start by maybe labeling the side. So I've got B on top. I've got D. I've got C. Okay. Now, I can do the green. And I'm going to take this green and kind of flip it around because it doesn't really matter how it's oriented. What matters more, okay, what matters more is that we can see that they're similar, right? The orientation of a particular shape does not matter in this case. Okay, so now we have B at the right angle. We have, let's see, A here making this base, and then we have the C up at the top. Actually, let's change that up. No, we want, yeah, we could do it like that. That will work. Okay, I believe. So let's take a look real quick. Actually, you know what I'm going to do? We need to make this look a little bit different. Our transformation actually isn't quite done. Because see how it was standing up? Let's try it like this. I'm going to lay it down. Boom. Boom. So here's the big triangle. And you'll have to forgive me. Kind of looks like a pointy nose. So I've got B forming the bottom. So here's B. Here's A. You can see it almost forms the top. And here's C. Now they're all lined up. So the reason that it wasn't right before is because when you're working with similar triangles, you always want to line up the congruent angles. So notice A is lined up with itself, D is lined up with B. We can see that these are similar. C is lined up with C. We can see that these are similar, right? So we can see the similarity. Now let's try to mark up some of the sides. So I had to finish actually with the second one. I had H as the height, Y is the base, B is the hypotenuse, and then on green, I had A, B, and we can in theory call this little C if we wanted to, okay, if it actually helped us, okay. Also, I should mention in this red one, H is the base. All right, so look, the alt GM or alt GM and leg GM, all they are is it's just one of the applications of similarity. So we talked about triangle proportionality theorem, which has to do with similarity. We talked about with regard to the uses of proportional relationships, such as measuring something based on the shadow, measuring the height of something, right? That was based on proportionality and similarity. So this is another theorem or set of ideas based on proportionality and similarity, okay? So let's see what we notice here. So taking a look, let's say that I want to know what H is in this particular situation, okay? So if we look here, well, look, the blue and the red are similar to one another, okay? And since they're similar, we know that the sides are proportional. So you might notice here, notice how these both red and blue have H in them. So notice that A plays the role of the hypotenuse in this particular triangle, right? Well, actually, I want a formula with H. I'm going to do one with A in a moment, but I actually want to start with the one with H in it. So notice, okay, that H and X have the same role in this triangle. So notice that X is the height of the red triangle. H is the height of the blue triangle, right? Also observe that H is the base of the red triangle, while Y is the base of the blue triangle. And because they're similar, this proportion must hold. And this is alt or else GM, because what it says is that the altitude is the geometric mean of the length of the two pieces of the hypotenuse. And a geometric mean, if you don't know, is of x and y is a number that satisfies this relationship, okay? Such that x is to h as h is to y. Or another way to look at this is that h squared equals x times y if we do the cross multiplication. Or another way is h is equal to the square root of xy. Now remember, in theory, this is a situation because I'm solving for h where multiple solutions can occur. In class, we talked about how the negative one will not occur because if you think about it, h is supposed to be the length of something and you cannot have negative length. So I just want to point out, though, that this is one of those, we talked about the tricky situation, when is there one, when is there two, okay? So here's another thing I notice. I want to suppose that I can try to find the sides. Let's see what I can do. Let's say that I want to find maybe A or B, okay? Maybe I want to know what A is. And I'm going to delete this in hopes that I might be able to salvage a little bit of room here. Okay, so I notice that, again, for example, the red and the green are similar to one another, right? And notice how I have an A up here and an A down there. So let's see if I can figure out what A is. So in the red triangle, A plays the role of the hypotenuse, since as we can see, it's across from the right angle. In the green triangle, C plays the role of the hypotenuse, since it's across from the right angle. Okay? Now, in the red triangle, X plays the role of the height, and in the green triangle, A plays the role of the height. Okay? So when I cross multiply here, what I get is A squared equals CX, or A equals the square root of CX, okay? So in other words, the length of a side, right, or a side, is the geometric mean of the entire hypotenuse and the side that is next to it or adjacent to it. So A is the geometric mean of X, because if you think about X and Y, which of the pieces is A touching? It's touching X, okay? So it's the geometric mean of the whole hypotenuse and the piece it's touching, okay? If you don't remember these, I do plan to post them for the test, but remember, these are just consequences of proportions. So if you use proportions and similarity in solving these problems, you are doing the right thing. You're doing the exact same thing as what out GM and leg GM are doing, okay? Now I'm going to do one last one. Suppose I want to find B. So what I realize is, well, look, it's the same idea, right? Because look, in the blue triangle, observe that B is the hypotenuse. But in the green triangle, C is the hypotenuse. Let me get that in green. Okay, now, on the other hand, in the blue triangle, right, Y try to do that in blue. Y is the base. Notice how it's on the bottom. It's the base. In the green triangle, B is the base. So this relationship must hold, right? The ratio of the hypotenuse to the hypotenuse has to be equal to the ratio of the base to the base. That's what it means to be proportional. And remember, we're assuming here that we're working with a right triangle. I mean, this would be true in other certain types of similarity, but in this case, just remember, these are all assumed to be right triangles, and that is an important assumption. Without that assumption, we wouldn't have a guarantee of that right angle, so having similarity would be a little bit more difficult. Okay, so now we know two things. We know three things. These are both considered leg GM. So we know that if I have a right triangle and I drop an altitude, the length of the altitude is the geometric mean of the first piece of the hypotenuse and the second piece of the hypotenuse. Okay? We also know that if I want to find a side, okay, any side is the geometric mean of the entire hypotenuse and the piece touching it. So A is the geometric mean of the hypotenuse and x, and B is the geometric mean of the hypotenuse and y. Okay? Now, someone has asked in class, Mr. Murray, why do I not just use the Pythagorean theorem? My answer to you is that in this case, you actually can, provided that you have enough information, so such that, for example, if I want to find a particular side, I have to know the two other ones, right? I can't get a unique answer for A if I don't know both B and C. I can't get C at all unless I know A and B, right? So you have that. The other thing that a student has pointed out, though, is that to find C, you have to square two numbers, you have to add them, and you have to then take the square root. And think about the operations there. That's three operations, which is, or four, and every operation you do, results in the possibility that an error could be made. And that error will lead to a wrong answer. Okay, so that's a possibility. Whereas if you just use proportionality, right, cross multiply, take the square root, you're right there, right? So, cross multiplying and taking the square root, some might consider that to be, half the steps. But again, I'm not going to force you to take one particular method. I want you to use a method that works for you and that gets you to the right answer in a mathematically sound way. Okay? So again, this all boils down to similarity, right? So we started by talking about how triangle ABC is similar to triangle BDC. Remembering to line up the letters. We talked about how triangle ABC is similar to triangle BDC. And then we talked about how, not in that order necessarily, but we talked about how ABC, red ABC, or rather ADB, okay? In any case, how AGB was similar to ABC, and we talked about the proportional relationships, and those, as we see just by our examination, give rise to these theorems, okay? So again, my goal is not to make you memorize them, but I do want to call your attention to them, okay? So again, if there's anything about alt GM or leg GM that's still confusing to you, I'd recommend you go back and take a look. I'm going to put timestamps in the description below, so you don't have to worry about, watching everything. You can skip through and find the stuff that's meaningful to you, okay? But I just want to make sure you have access to this explanation on kind of your own pace if you need it. So please go ahead, and if you need to, pause the video, kind of make sure you understand everything that you need to, and then in a moment I'll move on to a discussion of the different types of problems. All right, so let's take a look. So common types of problems, and if you know me, you know that I like to do the hot pepper scale. So I'm going to use the peppers to kind of describe the relative heat or difficulty of these certain problems. Okay, so here, and notice how I've used this labeling scheme that you see up at the top. Okay, so on a fundamental level, this would be a bell pepper. And I just want to say before I move on, real quick, I do want to say that any of these problems can be made hotter or milder depending on the numbers that have been chosen. So if I was to make these really ugly fractions, then this will become a much harder problem to do. Okay, versus on some of the other ones, if I make the numbers simple, those would become relatively easier problems. So this is not meant to necessarily classify every single problem of this type. It's more to give you like an average example, okay? So here's one where I just need you to find one number. It's the altitude, and I've given you all of the other pieces of information, okay? I've actually given you more to some extent than you need. And here, the idea is simply to set up the geometric mean, to solve, and to simplify as necessary. In this case, 4 doesn't go into 42, 9 doesn't go into 42, 16 doesn't go to 42, so we're not going to really be able to clean that up, okay? In another type of problem, maybe I'd ask you to find a little bit more. So here's A and B. Now this is a jalapeno or a habanero, so those of you who know your peppers know it's starting to get hot. So maybe you have to infer here that since the whole thing is 25 and this piece is 12, that this has got to be 13. And from there, you start to set up some geometric means. So you know that this piece A is to the whole hypotenuse as x, the adjacent side, is to A. And actually, we can say even better because we actually now know that 13 is x. Okay. Similarly, we can set up the proportion B is a 25, hypotenuse is to hypotenuse, okay, as leg is to leg, and solve that. And then finally, right, we know that H, right, 12 over 13, H over 13 and 12 over H, and we can solve that, okay? So a little bit more thinking involved. You notice that the more I don't give you, the harder the problem is in general. Now, this is an even more difficult problem because now there's a lot of stuff going on. I don't know anything about the hypotenuse. So even if I was to set something up, this would be weird, right? This would be like 15 over x plus y equals x over 15. So you see you got two letters there. And then here you get 23 over x plus y equals y over 23. Okay, so here, this is crazy, right? So actually though, interestingly enough, you get x squared plus xy equals x squared, x plus xy plus y squared. You can maybe try to add them together and do some kind of factoring. You might even find there's multiple answers. So what I'm getting at is this will become 15 squared equals x squared plus xy. This will become 23 squared equals y squared plus xy. Okay, so you can think about what, right? X squared plus 2xy plus y squared equals 23 squared plus 15 squared. And you can actually factor this, believe it or not. It's just x plus y squared equals, right? And we know that, right? 15 squared plus 23 squared, right? We know that. That's the Pythagorean theorem, okay? So in general, questions that I'm going to give you, what you have to understand is this. One, everything you need to know to solve that problem is in front of you. I cannot give you a problem that you cannot solve. Think whatever about me that you want. I've never given you a problem that you could not solve and then graded you on it unless the solution was literally no solution. That would be an exception. But in general, I've never given you a problem that was impossible to solve. And outside of saying that, expecting you to say that, but I'm not trying to set you up here. So you have to think about, a student asks, Mr. Murray, how am I going to know which one to use? It comes down to look at what you need and what is available, okay? Here, I need B. So if I'm thinking B, I need leg GM, right? Because this is a leg. I need a leg. I have an adjacent piece and hypotenuse, okay? So again, I'm not going to necessarily make you memorize alt GM and leg GM, but it's important to know, okay? So take a second, kind of recap anything here you need to, and then in a moment I will go ahead and move on to the next problem. All right, so I'll move on. And by the way, I believe that probably if you have an H here, some actual value, you probably get a more unique solution. Okay, so I'm going to go through a few. These will be ones for me to try, and then I'll kind of shut up and give you an opportunity to do some in just a moment. Okay, so here, all I need to do is I need to find H. So if we think about it, let's take a look. So I'm going to use the fact that I've got some triangle similarity here, right? I know that this triangle is similar to this triangle by AA, right? They all follow that pattern. So what I know is that, look, 4 is the height of the first triangle, H is the height of the second triangle. At the same time, right, H represents the base of this triangle, and 9 represents the base of the other triangle. So now I do my cross multiplication. I get H squared equals 36. So H is equal to 6. Okay? Simply using proportionality, though I will point out that this is alt GM. Okay? Now how about this one? So here, what do I know? Well, I know that X and Y are such that they add up to 61. So I'm going to take a look right here. So what do I know? Well, from leg GM, I know that 11 is to X. Well, actually, no. Rather, this hypotenuse, let's line it up with what we need to. This is the hypotenuse of this triangle, right? So I'm looking at the red and everything. So this is the hypotenuse of this triangle, and 61 is the overall hypotenuse. Okay? Then X is the height of this triangle, and 11 is the height of the other triangle. So I've got 121 is 61x, and if I do that out, I get 1 point. X is, I'll allow for now 1.98 about. It's not technically correct, so technically we should say X equals 121 over 61, okay? Or X is 1.98. Now we need to find Y, but we're actually good because X plus Y has to equal 61. So in other words, 121 over 68 plus Y is equal to 61, okay? We know that. Actually, sorry, 121 over 61, okay? This has to be true. And if I actually come through and multiply everything by 61, I just needed to figure out 61 squared. 3721. So 121 plus 61y equals 3721. Okay, I subtract 121. I'm trying to get y alone. 3600. Okay, so 61y equals 3600. Now I divide. Okay. And now I've got 59.01. So y is equal to 3600 over 61, which is approximately 59.0, actually 2. And notice that 59.02 plus 1.98 equals 61. Okay. Now I'm going to move on to the second to last one here. Sorry, kind of a psych. I've got two. So now I need x, a y, and a z. This is just taking it a step further and then also getting the altitude. Okay. So this one's a little bit tough because I actually don't know the hypotenuse, but I could actually figure that out, right? Because I know that 3 squared plus 4 squared equals c squared, which is the hypotenuse, and I know that 9 plus 16 is c squared, and 9 plus 16 is 25, and the square root of 25 is 5. So I know that x plus y has to equal 5. Now, since I know that the hypotenuse is 5, I have the leg GM, right? 3, this hypotenuse, is to the overall hypotenuse, as the leg, x, is to the leg, 3. So in other words, 5x equals 15, so x is equal to 3. Interesting. Sorry. 5x does not equal 15. There we go. So if anyone's counting my mistakes, that seemed weird, right? Like, how could that be the same as the hypotenuse? All right, step back. 9 equals 5x. So x equals 9/5 or 1.8. Okay, so what did I do? I said, look, this hypotenuse is the overall hypotenuse, 5, as this height of this triangle is to the height of the big triangle, 3. And then solve. Then you could get y. Well, look, they got to add up to 5. So that means y has got to be 3.2, right? If this is 1.8, this is 3.2. So add up to 5. The other way you could have done this problem is you could have done 4 is to 5 as y is to 4 and solve for y, in which case you would have gotten 3.2. Let's look and see if we can actually do that. Okay, so I have 3, no, I'm on the other one. I have 4 is to 5, hypotenuse is to hypotenuse, as leg is to leg. So 16 equals 5y, so 16/5, which is 3.2, equals y. Exactly. Okay. And now to get z, I've got to set up one last proportion. So I know that 1.8 is to z, as z is to 3.2. So I'll do 1.8 times 3.2. And let's see if that has a square root. So I'll do square root second for the answer. It does. Interesting. So z squared equals 5.76. So z equals 2.4. Okay. Lastly, I need to find x, y, and z. And this one's cool because actually z, x, and y are the 3 sides of one of the similar triangles. So that kind of is reducing the amount of given information I have. So let's start out by thinking about what would be an ideally, think about what we know. What do we know? Well, we know 20 and we know 5, right? So thinking about what we know, can I use the Alt GM at this point? I can't because I don't know why. Okay, I don't know, I'm not saying I don't know why. I know why. It's because I don't have this letter here, y. But notice that I have this leg and this leg right here. So I've got rather the leg of the whole hypotenuse and the leg of this similar triangle. And what I know is that 20 is to the whole hypotenuse, and I can get the whole hypotenuse. It's y plus 5. Okay? So that's equal to 5 over 20, right? Hypotenuse is to hypotenuse, as height is to height. So what that gets me is it gets me that 5y plus 25 is equal to 400. So 5y is equal to 375. So I'll divide And I get y is 75. Okay. Can I get z? Well, yeah. Let's set up the proportion. So if I can just get these over real quick. Nope, don't rotate them. Just move them. All right. So now, z is the hypotenuse, and we know the hypotenuse now. It's 80, right? Because if this is 75, this is 5. So I'm not going to, why would I do the y plus 5 again? I'm introducing a new variable. But see how the situation has changed? I'm not introducing a new variable anymore because I know what y is. So I don't have to pretend it's y plus 5. I know it's 75 plus 5. In other words, 80. Right? And then, so it's hypotenuse to hypotenuse. Now, 75, I know that's y, right? It is the leg. And z is the leg of everything. So see how knowing y, this letter y, allows me to unlock more information. If I didn't know this letter, then I would have this is the letter y, and this is, so this is basically y plus 5, and this is y. So essentially, I have two letters at the same time. I've got a z in my equation and a y in my equation, and that is not going to work. You always want to set up an equation that only has one letter in it. So here, what I did is I used the fact that this and this were given to create a ratio, or rather a proportion, that only had one letter in it. Once I figured out that letter, I used that to find one of the other ones. And what's cool is I don't need to know x, because I can't do the Pythagorean theorem. I can do the Pythagorean theorem, but I can't really, because I have two pieces of information that aren't known. Right? So now I'm going to do 80 times 75. And that is 6,000. That's equal to z squared. And now I'll take the square root. Oh, did I make a mistake there? All right. I think I put an extra. A little too excited there. All right. So we can't break that up directly, but we can break this up. 6,000. So 6,000, I believe. Let's see. So I know it's divisible by a perfect square. Is it divisible by 225? No. Let's see. Is it divisible by, well, it's divisible by 100. So we've got 60 and 100. But then 60 is 15 times 4. So that means 6,000 is divisible by 400. Yes. Okay, so z is equal to 20 square root of 15, because 20 squared is 400, and 15 squared, the square root of 15 squared is 15, etc. Okay? So that's z. Last one we have to get is x. Okay? So we know now, finally, that I'll just erase this little scratch work that I did. Okay, and I'll just make a note here. It's 415. Okay, so now 5 is to x, as x is to 75. So I've got x squared equals 375, and I know that because I did this over here. And now I've got to do the square root of 375. I know it's not a whole number, but I know that 375 is divisible by 25. And interestingly, it's 15. Isn't that interesting? So basically what I have here is I've got 5 square root of 15. Okay? And that is what I have for that right there, okay? So folks, I hope that this kind of made sense to you. Please take a moment and go back and make sure you understand some of the different kind of problems I did here. And then in a moment, I will move on and talk about some ones for you to do. All right, here we go. So these are ones for you to try. So what I'm going to do is this. I'm going to zoom in a little bit so we can only see the first couple. I'm going to ask you to take a moment. I'm going to ask you to pause the video. I'm going to ask you to try the first couple problems here. So in the first problem, I'm only looking for you to find the altitude. And in the second problem, I'm giving you the hypotenuse. And I'm looking for you to use that to find the two pieces based on the given information. So please take a moment, pause the video, try these two problems, and then when you're done, unpause, and we'll see if you were right. All right, here we go. So we need to find h. So to find h, okay, again, you can think about it in terms of similarity. Got the red triangle. And actually, what we want to compare it to is not this one. Compare it to this one. Okay, so observe that again, 10 is the height of the red triangle. H is the height of the blue triangle. Okay? Then, for the other triangle, H is the base of that triangle, the bottom, and 15 is the bottom of the other triangle. So I multiply through, and what I get is, I do the cross, h squared equals 150. So h is equal to the square root of 150, okay, and 150 so it is 5 root 6. Okay, so we get 5 times the square root of 6. Okay, all right, on the second one, we're aided by the fact that we do have a 41. Okay, so what we're going to do is we're going to solve for x and y. I'm just going to solve for one and get the other. So in this case, you have a couple options. You could have either solved for x and then gotten y. You could have solved for y and then gotten x, or you could have ostensibly solved for each of them individually using the ratios, okay, or rather the proportions. So again, it all comes down to similarity, okay? So I've got this triangle here. I've got this triangle here. I got that triangle there, okay? So notice, 9 is the hypotenuse of the red triangle, and we know that for the green triangle, 41 is the hypotenuse. Then we know that x is the leg of this triangle, the height, and 9 is the height of the green triangle. Okay, so cross multiplying and simplifying, I get 81 equals 41x. So I'm going to do 81, 41 into 81. 1.97, darn. So x equals, I wonder what we'll get if we do it with y. So let's try the other one, right? So if I set up a similar proportion, 40 is the hypotenuse of the blue. 41 is the hypotenuse of the green. Okay, now we got to be careful here, but it is true that y is the base of the blue. I need to make this blue. Y is the base of the blue, and then for the green, 40 is the base of the green. Okay, so I can do the same thing. So this is going to be a little bit more difficult. I believe this should be 1600. Yep. 1600 over 41 equals y. That's what we end up getting, because you get 1600 equals 41y. You would divide. And what is 1600 over 41? All right, interesting, right? So if I add 39.02 to 1.98, I do get 41, right? Because you get to 39.02 and then it goes up to 41, or rather 40.02 and then it goes up to 41. So this does work. I would honestly prefer, rather than leaving a decimal like that, because there's probably more to the decimal than what you can see. The calculator can't go on forever, okay? So I, to be honest, would kind of prefer you leave it as 81 over 41 or whatever. That's fine. You don't have to get the decimal from it. That's fine. Okay, so please make sure you understood these two, and then in a moment I will move on to a couple more you-try problems. All right. So these are my last two problems for you. And these two problems, and I'm sorry, I know it's a little cut off. Let's see if I can get that. There we go. I need you to find for me x, y, and z with the given information. Okay, so please again, pause the video, try to find x, y, and z, and then in a moment unpause and I'll show you how to solve these problems. All right, so let's take a look. I need x, y, and z. What am I given? What do I need to find? So I need to find an x, I need to find a z, I need to find a y. Now let's think about this. If we think about this, what do I need to solve z? I need the alt or the alt gm. But I don't have the information. I don't know this piece right now. Okay, it's not given to me. Although I do have 25, so could I figure that out? It looks like I can, right? So if the whole thing is 25 and this piece is 9, then this piece is 16. So they add up to 25. So then I can find z, because 9 is to z as z is to 16. So in other words, if I do 9 times 16, I get 144. So z squared equals 144. And you might very well know that means that z equals 12. Now, I need y and x. So let's think about it. What am I given? What do I need to find? I need to find x. So again, it comes down to similarity. We have this red triangle versus the whole thing. So if it's just setting up proportions, right? So in the first one here, x is the hypotenuse. In the big triangle, 25 is the hypotenuse. In the red triangle, 9 is the height. In the overall triangle, x is the height. So what I get is, I get 225 equals x squared, and you might well know that that means that x is equal to 15. I happen to know that square root. If you don't, you would do it on your calculator. Finally, y can be set up with a similar proportion, because I know that this blue triangle is also congruent to the whole thing. So I'll set my proportion up. So I know that y is the hypotenuse of the blue. 25 is the hypotenuse of the whole thing. Then 16 is the base of the blue, and 16 is the y of the whole thing. I believe this is 400. It is. So y squared equals 400, which means that y is equal to 20. And notice if you do 15 squared plus 20 squared, you get 625, which is 25 squared. So we get z is 12, the geometric mean, and then x and y. Now, does the order matter? Not really. It now, in a sense, if you did not know this was 16, this problem would have been, I believe, not possible to do, as is. So in the beginning, you had to have everything being 25, the total length, so that you could figure out that 16 was the other piece, so that you could then execute those things. So without knowing that was 16, Z would have been out of the question. Now, knowing it's 16, in theory, that means you could have done Y and then X and then Z. You could have even started with X. You already had everything you needed to find X. So I don't care the order you do it in. And if for Y, you could use the Pythagorean theorem, right? So, for example, you know that 25 squared plus 15, let me go back. So you know that 15 squared plus y squared equals 25 squared, right? And you could have solved that. 15 squared is 225, right? So I've got, in a sense, if I take 25 squared and I subtract 15 squared, that gets me 400, which is y squared. So y is 20. So see, I did it with the Pythagorean theorem, and you can too. That's okay. But you have to be open to the fact that sometimes it's easier to maybe not do it. Sometimes you might not have the information to do it. But think about it. Without knowing x is 15, just knowing the hypotenuse is 25 and the adjacent side is 16, you can find y just based on similarity and not using the Pythagorean theorem at all. And I personally think that's really cool. All right, going on to the last one. This is going to require a little bit more algebra. So think about this. What are we given? Okay, we're given these two pieces of information in the same triangle. So I can't solve for x because I don't know y. I can't solve for z because I don't know y. I don't know the whole length, so I can't figure this out. So what I'm going to do is I'm going to do this. I'm going to know that, look, this is the hypotenuse of this little triangle. 36 plus y is the hypotenuse of the big triangle. 36 is the leg of this triangle. 60 is the corresponding leg in the other triangle. So I'm going to now do some cross multiplication. Okay, so now see there's only y there. So I've got 3600. And by the way, you can verify if I do 60. Okay. So 2304 equals 36y. It's divisible by 4 and 9. Right, it ends in 04, 4, 7. So that could be a good sign. It's divisible evenly by 36. Nice, 64. So what I'm saying is, if you look at the digits of 2304, 2 plus 3 is 5, plus 4 is 9, plus 0 is 9, right? So it's a multiple of 9, the digit sum, so it's divisible by 9, and it ends in a 4. The last two digits are 0, 4, rather, and that's divisible by 4, so it's also divisible by 4. And since it's divisible by 4 and 9, chances are it's divisible by 36. Okay? And also, it's divisible by 2, and it's divisible by 3, because it's divisible by 9. So it's divisible by 2 and 3, so it's divisible by 6. And 36 is also divisible by 6. So that's also a good sign. Okay? So now, y is 64. Making this whole thing 100. So you got an option, right? So first of all, I now can figure out x. 36 is to x as x is to 64. By the way, you could have x is to 36 as 64 is to x. The proportions are the same. Okay, so again, there's not necessarily one way to set it up. If you get the right answer as me, that's okay. So now I know that 2304 is x squared. And the good news is I actually know that 2304 is going to work because I literally did this a couple rows up. Okay, it's going to be 48. Okay, because you got to do the square root. That's interesting. 36, 48, 60. Kind of like multiples of 12. 64, that's not a multiple of 12, though. Okay, now, a couple ways I could get z. I could do Pythagorean theorem. 48 squared plus 64 squared is z squared. I know that 100 squared minus 60 squared is z squared. Lots of ways to do it. Okay, I'm going to do z using geometric means. So z, the hypotenuse, is to this whole hypotenuse, which is 36 plus 64, or 100, okay, as 64, the base, is to z, the big base. So 6400 equals z squared, okay? Notice 80 is equal to z. So think about it. In my opinion, and you can disagree with me, I truly believe that this was way easier to do the z over 100 and 64 over z than it is to do 64 squared minus 60 squared. My personal opinion, you can feel free to disagree with me, but that's what I believe in that regard. So lots of ways to do it. You find a way that's comfortable for you, but the idea here, folks, is that we're applying similarity, right? In the beginning of the unit, we talked about dilations and how dilations show that shapes are similar to one another from a geometric standpoint. Then we started to talk about proportionality and the theorems, right? Side angle side, side side side, right? Side angle side, right? Side angle side, side side side, and angle angle, right? We talked about similarity. We talked about triangle proportionality, right? We talked about measuring things using different kinds of similarity, and now we're culminating in things we know about right triangles that we're piecing together, based on the similarity and how the altitude of the triangle creates two triangles that are similar to each other and the whole triangle. It's really, really cool. So, folks, I hope you enjoyed the video. I appreciate your persistence. Stick with it. I know that if you continue to work through this, that you're going to find that the test is not going to be as tough as you think. You're going to find that the problems in the test are very manageable, okay? I'm challenging you because I believe in you, and I know that you're capable of doing the difficult problems, okay? And you got to remember, right, just like I'm getting at, you can do it. All right, folks? So thanks for watching. I hope you enjoyed the video. Make sure to subscribe and subscribe to alerts so you can get alerts for all my new videos. And don't forget to love math, and have a wonderful day.